Ladies and gentlemen, welcome. Are we all excited? Yes? Good, good, good. I'm very much looking forward to have this panel discussion with our amazing panelists with a topic about deploying AI to solve the mysteries of the universe. Doesn't sound that quite exciting? We have seen already so many AI applications also working on Earth, but what about space? I think everyone can answer the question, if we look up in the stars, what could be out there? How can we perceive something so big? And today we're actually going to discuss that topic with one of our panelists. And ladies and gentlemen, let me introduce these panelists to you. First we have Dr. Vandy Verma. She is the Chief Engineer of Robotic Operations at Mars 2020. Welcome. And Jet Propulsion Laboratory, JPL, at NASA, not to forget. The second speaker, we have Professor Anna Scaife. She is the Professor of Radio Astronomy, University of Manchester. And the third speaker, we have Professor Shirley Hu, Founder and CSO, Parallaxis Technologies, Group Leader, Cosmology X Data Science, and Center for Computational Astrophysics in the Flatiron Institute. So when we look at the title, Deploying AI to Solve the Mysteries of the Universe, let's first focus on the first part of the title. When we talk about deploying AI, can you maybe come up with some examples of what you already work on in terms of deploying AI in space technologies? Maybe Vandy can start first, Dr. Vandy Verma.
Yeah, in terms of deploying AI, almost everything we do in space robotics could have an element of AI that we could deploy because it really helps to be able to utilize the data and information we have in context in order to solve the robotic problems. And some examples, are driving, navigating across the surface of Mars. And another one is, finding interesting targets to take science observations on. So those are some of the examples we directly work on. But also just planning, determining what to do is another aspect that you can deploy AI in.
Wonderful example, definitely. And Professor Anna Scaife, what is your opinion about it? Some examples that you can give us?
Yeah, thanks, Ramon. So I think it's probably true to say that astrophysics is one of the only sciences, if not the only science, which is entirely based on inference, in the sense that in astronomy, you can never change the underlying experiment. You can never reobserve the same star at a slightly different temperature. You can't change the conditions. And so the statistical analysis that we do in astrophysics every day is a form of AI. And the nature of that inference is very closely linked to what is done in the broader sense in artificial intelligence now, in a much wider range of sciences and, of course, in industry.
Exactly. It's important to measure these new innovations as well, definitely. What about you, Dr. Shirley Hu?
Thank you, Ramon, for the good question. AI, I think, is used across many stages when you explore the universe, and I see many examples, such as the design of spacecraft. We actually use AI to model the turbulence around the spacecraft when it takes off. That actually uses AI right now. And then at the coordination stage, when you deploy, for example, the satellite, how would you coordinate the positions? We also use AI. And then also the analysis stage, where we take the data of all these Earth data and space data, how would you analyze them together?
Exactly.
So that's a lot of them, I think.
It's harmonizing the different fields as well as measuring it, and at the same time, innovating at the same time. So it's interesting. Talking about the second part of the question, the mysteries of the universe. It sounds so big, but what kind of mysteries do we actually talk about here? Can you explain it first? What kind of mysteries do you think might be exciting for yourself, but also some mysteries that you've solved, let's say, yourself in your own field of study?
Yeah, so one of the mysteries that we're currently working on that I think would be really exciting to know the answer of is could life ever have originated anywhere else in the solar system? And right now we're on a mission to collect samples from the surface of Mars and bring them back to Earth so that we can study them to know if they might have some biosignatures of life. So I think that's finding life in our own solar system and the planet really close by would be really exciting, because it would mean that it's much more likely for life to exist elsewhere if it exists so close. And so I think that would be very exciting, and I'm looking forward to that.
Definitely, yeah, something practical that we can work on, definitely. What about you, Professor Anna Scaife? What is your mystery you would like to solve?
So one of the driving scientific one of the driving scientific questions for the telescope that I work on, the Square Kilometre Array, is understanding how the first stars and galaxies were born in the universe. So we now know a lot about how the universe came into being through the Big Bang, but after the universe was first created, it was empty. And so there's a point in cosmic history at which these first stars and galaxies were born, and we know roughly when it happened, but we don't know exactly how it happened. And so hopefully that's one of the questions we're going to solve in the next few years to decades.
Yes, takes time. Professor Shirley, what is your opinion about it?
It's also quite personal. That's why I did astrophysics and computer science, was that I want to understand how I got here myself. So that started with the question, how did the universe begin? What's inside the universe? And how it evolved to get to us. So I think these are the biggest questions I'm personally really excited to know about.
Starting from the source, whatever that might be, indeed, is something that is definitely something worth exploring. Yes. Next question. As we talk about robotics and AI, Dr. Wendy Verma, you worked also on the Mars 2020, as you mentioned as well. Can you tell a little bit more about this rover? And in addition, what did you work on, let's say? What was your role in that?
Yeah, so the Mars 2020 mission has the Perseverance rover and the Ingenuity helicopter in it. So the Perseverance rover, the mission, is part of the Mars sample return mission, and it's the first step in that mission to collect and cache sample cores so that we can bring them back with a subsequent mission. But also, when we collect these cores, we want to study the environment to capture the context in which it was collected, and that's part of the mission. And I worked on a number of different aspects. I work in robotic operations, which deals with all of the navigation for the rover, autonomous or guided, and the robotic arm deployments, the sampling, and the interface with the Ingenuity helicopter. Once the missions land, that's what we're doing. But before they're deployed, I worked on some of the technology on the rover to do autonomous robotic arm positioning and autonomous science, which is figuring out what the interesting targets are. So some of that, I worked on the algorithms and programmed the software that runs on the rover.
Perfect. So a lot of things combined. It's very important to have all these aspects together and to harmonize everything in order to have this rover up and running and working as well. Definitely. Professor Scave, you have been working on the SKA, or so-called Square Kilometre Array telescope. Can you tell us a little bit more about that telescope and what it actually does? Because it's the most ambitious project, as I've understand, in terms of radio telescope. Can you tell us a little bit more about it?
Yeah, so thanks. So the SKA, the Square Kilometre Array, is going to be the world's next big radio telescope. It's a massive international project. You can see some graphics of it in the background here. And it's a radio telescope, but one of the most challenging aspects of it is actually the data flow for us. And that's where AI becomes incredibly important, because the data volumes coming out of modern radio telescopes, thanks largely to very high digitization early in our processing, the volumes of data are huge. So the raw data volume from our telescopes, if we saved all of our data, we would be saving zettabytes of data per year, which obviously is ridiculous. So we compress that down to a mere sort of 20 terabits per second, and then we have to extract the science from those data. And of course, that's just not feasible these days. There aren't enough astronomers. There aren't enough grad students to do it. If there are enough grad students, there certainly isn't enough coffee. So we need AI to really help us extract the science from those huge data volumes.
Wonderful. Great stuff. And Professor Hu, in 2019, an article has been published by the World Economic Forum entitled "The World First AI Simulator That Knows Things That Shouldn't." What is it actually about, and what are the benefits, but also the challenges with such simulations of the universe? Can you give us like an image or something to describe us, how it looks like?
Thank you, Ramon, for bringing up our work that was mentioned by the World Economic Forum. Let me just say, this AI simulator is not taking over the universe. Some people were asking me about that. It does know things that we didn't think it should know about. So let me explain the network a little bit and what this AI universe simulator does. What it does is that we use something called, for the aficionado in AI here, we use something called a style neural network that can actually generate the universe in matter of seconds instead of like millions of CPU hours. And so it's much, much faster. And what surprised us is that we trained this AI system with one set of latent parameter about our universe. So very specific amount of matter, something we call dark energy. And it has figured out how to simulate other universes that we did not train it with. So it has somehow figured out how to extrapolate and generalize to other universes we have not taught it. So this isn't a mystery. We still haven't solved it. So maybe you guys can give me some ideas.
Yes, yes. And it's great that actually scientists can actually answer those questions for us as a species, but it needs to be continued, of course. So that's very interesting to also have that in mind. Dr. Wendy Verma, you also appear in several documentaries called Science in the Extremes. Why is AI so important in such environmental extreme, let's say, approaches or something like that? Yeah.
Right, so space is one kind of extreme environment, but we also have a lot of extreme environments on Earth. And what's interesting about them is a couple of things. The first being, because it's an extreme environment, often we don't have a continuous communication in that environment. So we're deploying a robot. It might be, in an outer planet, or it might be underwater, or in a cave, and for long periods of time, we won't actually be able to communicate with it. So it's important for it to be able to perform the experiment on its own and then relay the data back to us. And the other aspect is, extreme. It's an extreme environment, and so often the lifetime of the robots we send on these environments is questionable. It's uncertain how long they'll last. And so it's also important for us to be able to conduct all the science and, again, relay that information before the mission ends. For example, if you go to Venus, which is a very extreme environment, that is going to be very essential.
And then you can copy that, let's say, abstraction to other also in research and experiments as well. Yes. Professor Scaife, you've been ranked as one of the top 30 scientists under 40 by the World Economic Forum in 2014. Having that in mind, what exciting projects are you currently working on, and what do you aim to achieve next?
Gosh, that's a very open-ended question. So at the moment, a lot of our work is around quantifying and calibrating the uncertainty associated with AI outcomes, which is very important because when we propagate the outcomes of our models into astrophysical parameter estimation, they affect the parameters of the universe if we get them wrong. So understanding how uncertainties propagate through particularly deep learning models is a key aspect of my current research. But one of the most novel things we've been working on recently is actually the use of quantum machine learning as applied to astrophysical models. And we're actually finding that if we get the quantum encoding correct, it works very nicely for a range of astrophysical models. And we're hoping to take that into a more realistic quantum computing scenario in the future.
Yes, yeah, we've seen also some examples here in the World Summit AI about quantum computing. So it's definitely interesting how that can intersect with also AI and space technology, exploration. So it's a holistic view about all different disciplines coming together, having the bright minds together, and come up with solutions on how we can get to that next phase, let's say. So it's a good summarizing. Professor Hu, your group has published work on discovering physical laws by combining machine learning and genetic programming. Can you explain machine learning and combined genetic programming, and what do you see as potential challenges and pitfalls in your field of work?
Thank you, Ramon, for such a nice question. You actually just saw the video earlier where you have seen all these planets moving around. So what happened is that we combine machine learning and genetic programming in this particular work, where we actually rediscover Newton's law by looking at the NASA data of all the planets and moons for the last 30 years. So what's so special about it, right? Because you already know Newton's law. What's so special about it is that, A, we took just the data, say the first 25 years of the data, we feed it to this AI system, and it has been able to basically predict what the next 5 years, the data they has not looked at, for all these planets and moons and where they are supposed to go, find all the masses of all the planets and the moons. And what's so interesting is that usually you can use an AI system and predict what's supposed to do next, and it's very good at this. But what we did is that we opened up this black box AI that people always talk about interpretability, explainability, right? Can you explain to your clients, to your community, to your users, why this AI system works? In our case, we were able to open up this black box and then explain to us with this symbolic regression method, which we looks at all the possible equation in the search tree and find the correct equation that this AI system picked up. And actually picked up the correct equation, which is the Newton's law. And the interesting thing is that it's not just picking up Newton's law because we know it's not exactly correct, because we know general relativity is actually the correct one so far. It actually discovered a law that is slightly closer to general relativity, but it doesn't prefer it as much because the data wasn't good enough yet. So I thought there's a lot to do to discover new laws, rediscover old laws, and just opening up the black box that's not possible before. So I'm very excited about this merging between AI, this neural network method we call graphical neural network, and genetic programming, which is this huge search algorithm for symbolic expressions together to explain the AI that had explained the data.
I really also like the fact that you mentioned the word communication, because sometimes these complex, let's say, issues about AI also need to be explained in a more simple way for people that want to get into the field and want to understand this concept. Because many times you can see that AI can be a very complex issue, but if you use certain creative methods of communication, of words, of sounds, of images, as you mentioned, people learn in different ways. And sometimes people are visual, sometimes written with words or literature. So I really like the fact that you mentioned that you keep in mind, once you have working with AI, that it also can explain it in a more simplified way from a human perspective. So that's a
This is
point.
an interesting problem. I mean, I don't know if I should answer this,
Sure,
but
go.
how do you communicate what the network has learned
Yes.
to the whole community that's using it? I think it's a very important and something we need to solve. Otherwise, people won't trust AI. And there's also the trustworthy AI part that we should
Yes.
talk about.
Yes, especially also talking about the universe and space in general is already a complex topic. So how do we also explain that part to the people? It's an interesting topic to
Hopefully.
definitely go about. So when we talk about planets or stars, there has been also a debate about mining rare earth elements, such as you had mentioned as well with the Mars 2020 rover, as it seems to be one of the most promising space venture projects of all time. Given the predicted scarcity, pollution, and unsustainable practices that we have on a global scale, what roles can AI play in this effort to mine rare earth elements and resources on other planets?
Yeah, I think there's, multiple layers of sort of going for the rare earth elements. If you're going to, one is just detecting where they might be. So I think there's a lot of learning that you can do in figuring out where you would go and actually mine. And then in situ exploration inevitably involves a lot of uncertainty. And when you're interacting with the surface, it's very similar to what we do with, say, coring or other operations. It would be a lot of techniques to map it to what we've tried before and active learning potentially in order to improve the interaction on the surface, especially if you're doing it autonomously. So I think there's a lot of potential there.
Also adapting along the way, let's say, to the environment as well. Yes, great. Yes, so maybe Professor Scaife can also comment on that part as well.
Yeah, so I mean, so this is somewhat more out of my field than Vandy's, but I suspect that any kind of routine mining operation that we might do on Earth, as soon as you take it into such an extreme environment, you have to innovate in a way. And I think we've probably got a lot of work to do in Earth environments in order to prepare for this. So actually, I think we'll need to look quite carefully at the use of AI in extreme environments on the surface of the Earth before we deploy it into space environments. And so I think there's probably a lot of exciting innovation that can go on in that field first before we even think about mining in space.
Step by step, indeed, yes. Professor Hu, what is your comment on that?
I'm a total planner, so before I even go anywhere close to mining, I will hope that we will analyze all the data, that we look at all the moons and planets very carefully before we go. And to do that, I think there's a lot of AI techniques that people have been deploying to analyze the data that we collect, but also get the telescope to get better resolution. So they have been deploying AI in adaptive optics systems, I think, across the world. The adaptive optics, for those people who don't know, is that if you can change the mirror slightly on the telescope to make the image sharper. And it's a very cool control loop that actually you can optimize. And so we can do that with AI right now to actually make the resolution much higher for these images of planets and moons before we can go ahead and mine it. Because what if we don't have anything up there worth mining when we
Right.
go there?
Yes, so it's also recognizing these patterns and also what is out there, and actually, yes, perfect. So, given all your expertise combined, and this is maybe one of the biggest mysteries that might be on their mind when we talk about the mysteries of the universe, do you believe that we as a species are the only conscious life forms in the universe? Dr. Vandy Verma, you can go ahead.
So, the probability, given what we are finding, especially if you look at the rate at which we are finding exoplanets, is there's a high probability. So, I would say probabilities rather than a belief, but I do think there's a very high probability that such life would exist in the universe, and that would be very interesting. And it's very likely that we will find it through AI first, and that it might even be that the AI is first aware of the fact that we detected it in a manner because it's the detection. So that could be really interesting. And then the second part is if you're actually going to venture into any of those areas, it is almost certainly going to be robotic. And so that's, I think, another layer of this which is interesting, is that we're building these capabilities that are potentially going to answer these questions for us.
Exactly. Also something for future generations to look out for, definitely. So what is your comment on that, Professor Scaife, about conscious life out in the universe?
So I agree with Vandy. I think statistically it's likely, which is not quite the same as a belief, but yeah, it's definitely a positive indication. I mean, from a radio astronomy perspective, what we're typically looking for when we explore the search for extraterrestrial intelligence is civilizations that are equivalently advanced to our own. So we look for what are known as techno-signatures in our data. So, for example, something like airport radar. How far away could a planet be that has airport radar, and we would be able to detect it from the surface of the Earth? And there's actually an increasing amount of work using AI to separate out those kinds of techno-signatures from, for example, our own man-made radio frequency interference. And it's one of the science cases for the Square Kilometre Array is to perform those investigations.
Interesting. What is your comment on it, Professor Hu, about this interesting question that might be on everyone's mind?
No,
about this
I'm
topic?
actually thinking about what you were saying, that it will be interesting to do anomaly detection from these data set, just like something completely different from the usual radio signature on the ground. And that will be amazing to find something special.
It's definitely a sort of needle in a haystack style anomaly detection problem.
Absolutely. But I did do some calculations when you asked us that
Yes.
question. So we actually have about 100 trillion stars in our Milky Way, and we have about 100 billion galaxies, like the Milky Way-ish, in our universe. So I did actually look into those many zeros, about 10 to the 25, which is 1 with 25 zeros behind the stars in the universe. If, say, 1 out of 10 of them has a planet, and say 1 in a million of them has a habitable planet, if you look at all the calculations, say, it would be really hard that we're the only conscious life form, just looking at the probabilities. So I hope we're not just the only one, but hopefully the other ones are nice.
Yes, I like the I like that mathematical equation that you made. It puts it into perspective, and I think that's so important about this topic, that we put things into perspective, and then we understand it from that point of view, but also are open for different other ideas. Correct? It's actually a great point. So the next question is more based on if we look at it in the future, because we also need more young people to be in this industry and to look at things from their perspective, because there's a lot of young people also in the audience that also have their ideas and they also want to be heard, they also need to voice. So this question is more about that part as well. So if you look at the near future, regarding the developments of the intersection between AI and space, how can young professionals and graduates contribute to this in your own field, let's say? What is the best way to make impact as a young graduate in your field?
Yeah, I think the ways in which some of the younger graduates can contribute is enormous because the field is growing at such a huge rate that the various prongs that we can explore of potentially applicable areas are so many. So picking the areas that you're most interested in, whether it be, deep learning to see if you can detect various constraints that we have. I'm talking more about robotics, but we were talking earlier about doing in situ exploration. Whether it be that or looking at what is an interesting targets, employing these techniques and working with people to find problems and define them, but taking that problem into your own domain. It's sort of like a mini thesis. Is really interesting. And that's actually how we find new things to pursue, is by exploring many of them, iterating on them, and then seeing which ones are the most promising, and those become our missions and becomes what we pursue. So, they're very much a part of our exploration. And we do a lot of proposals and work with students all the time.
Can you mention some examples maybe to us about what you're referring to? Some examples of, let's say, the intersection between that as well.
Yeah, I mean, earlier, I think Anna was talking about things like quantum computing. We have people looking at that for robotics. Now, when you look at something that is kind of like a new idea that is different enough that we haven't yet proven it to invest like a large mission on it, that's the kind of thing we do have students working on. To the extent of, when we first started looking at a snake robot to go into the vents of Enceladus, when the mobility system is such, it's actually more efficient to have an autonomous snake robot. That was another project where it's like, let's pursue this, see if we can actually build one. So those are examples of ones, and there are many. And in fact, it's very much a process together with the students and us having problems, working to see what are you interested in. Inevitably, at that intersection, we can find problems that are both beneficial and interesting. So,
Interesting. Yes, great point that you're making there. Professor Scaife, what is your opinion about the young students and graduates? What would be the biggest impact they can make in your field of work?
Yeah, well, perhaps I'll pick up on the same theme that Vandy just introduced. So when we were looking at our quantum machine learning models, one of the things we were very interested in was how they behave in different quantum computing environments. And so we partnered with Atos, who are a very large computing company, to run an internship where we took a graduate student who came out of their PhD and worked jointly with my research group and with Atos in their quantum learning machine environment in order to develop our algorithms and look at them in different scenarios. So I think those kinds of partnerships between industry and academia are very valuable for helping people to get involved in new research themes. But also, just quickly, one way that people can dip their toe into astrophysical machine learning if they want to is through the Zooniverse. So the Galaxy Zoo is used to train deep learning models, and anyone can log on. So I recommend it if you're interested.
Interesting. Thank you. What about your opinion?
I actually just want to respond to what Professor Scaife just mentioned, that the intersection between industry and academia, I think, is very fruitful. Some of our work that I mentioned here, for example, the rediscovering the orbital mechanics with AI, is partnered with DeepMind, for example. And their know-how in graphical neural network combined with our research direction in genetic programming and combination together actually made it possible. So it wouldn't be possible without those intersection, this interdisciplinary discussion. And I think that's actually a great direction to really go about. And now my students are all very happy to realize that they have not just recommendation letters from the academic people, but also from the industry people. And then a slightly more personal note to this is that I think to be in an intersection, it'll be very important to be brave, to be audacious, to look for ideas that no one else has done before, and just not be afraid and pursue it. At the beginning of doing AI and astrophysics, it was 10 years ago when I did it, when I first started, and people were so doubtful that this is anything meaningful. And here we are. We've done quite a bit since, and I'm very excited to say that I didn't regret that decision, but it took a little bit leap of faith. So take your leap. That's it.
Be brave, be audacious. That's exactly the words that we can close this panel. Thank you so much for joining us as well, and also our panel discussion. Yeah, thank you for that.
Thank you, Ramon.
Can we have one part? Yes.